Well, good morning, everyone. As the first speaker of the day, I feel compelled to wish you all a very warm welcome to B-Sides Knoxville 2024. You probably weren't all expecting to hear a British accent. Let me tell you two things about that. Firstly, I promise I'm not faking it to sound smart. No matter how many drink tickets you give me later, I'm going to sound the same. And secondly, I actually live in Knoxville. This is the third time I've been to B-Sides here. The first time I'm actually speaking here. And the content of this talk was really born from discussions with you all over the last couple of years. But I'm going to get to that in a second. Firstly, in time-honored conference presentation tradition, here is some more about me that you both don't want to know and will instantly forget. I've worked in InfoSec for 20 years. And there's been a pretty even split in that time between hands-on technical roles and security leadership roles. Back when I was technical, I've co-authored a couple of books, co-authored Shellcoder's Handbook 2nd edition, if anyone is familiar with that. I presented at Black Hat, DEF CON, OWASP AppSec, RSA, on all manner of things from hacking firmware through to web application security. And on the security leadership side, I've built InfoSec teams. I've built application security teams, multiple versions of application security teams, which is what we're going to talk about today. And I've been the CISO of a public company for 5 years now. Now, during that 20-year career, a lot of the time I've spent working with Silicon Valley-based tech companies that put a real high premium on, high importance on security and put their money where their mouth is, frankly. And during that time, when I've given presentations or been on panels talking about AppSec, what I didn't really realize at the time was that I was speaking from this kind of gilded position of having budget and headcount and room to experiment to figure out with an application security program what really works and what really doesn't, right? But I know a lot of people in AppSec are not in that position. You know, maybe you're just starting out in AppSec, starting out the program at your company. Maybe it's a program that's existed for a while, but you're really struggling to get buy-in from engineering leadership or getting pushback from your engineers. Maybe you're just completely confused when you see the myriad of things that we tell you should put in your application security program. So we're going to tackle some of those topics today. You know, a lot of application security presentations will tell you, we'll talk about various technologies and processes, but they won't really tell you what you absolutely should do and what you absolutely shouldn't do. So I'm going to try and take a bit of a stance on that. I want to start by briefly discussing why we do application security at all. You may think there's a simple answer to that. Simply, we want to make our software secure. Right, but this is, let's come up with a mission statement. This is my application security mission statement. Let's dissect it a little bit. Firstly, we want continuous improvement. We want that in all aspects of our information security program. Application security is no different. Tools, technology, processes, our understanding, it's all constantly improving, and we want to take those improvements and feed them back into our program. So continuous improvement. We want to reasonably minimize security defects. The lawyer in me made me put the word reasonably in there, right? That's the acknowledgement that we don't have infinite sort of budget on application security, infinite time or money to solve the problem. So really it's the best effort with what we've got. And then we want to do application security in a consistent, comprehensive, and measurable way. So we want to be consistent. We want to run these processes over time and get the same quality of output each time. We don't want that to vary wildly because it might mean we then miss things. We want to be comprehensive. We want to make sure that this covers all of our critical applications, perhaps all of our applications in its entirety. And we want the program to be measurable. We can't do continuous improvement unless we can actually sort of measure how effective these processes are and feed that back in. So this is why we do AppSec. But how do we do it? Well, no application security presentation is complete without discussion of the software development lifecycle, the SDLC. And you'll see a lot of sort of riffs on this, but this is This is mine, and we've got these 6 different phases here. So it's pretty straightforward. Let me run through it real quick, those who are on the same page. Applications typically start out with product management, writing some kind of spec or defining the requirements of what it is that actually needs to be built. Then we enter the design phase, which is normally a collaboration between a few teams, engineering, product management. If it's got a user experience, then UX will be in there as well. And this is really the phase where we design the thing. And then the fun part, engineering go off and build the thing. And then we need to test the thing. That might be engineering, or it might be a dedicated quality assurance team. And they may do manual testing, or they may do automated testing. And then we actually get to deploy the thing. Yay, the thing's deployed, long live the thing. And then 5 minutes later, the thing is down, and we enter the perpetual maintenance of the thing. But I mean this, we're not considering security at this point. This is just how engineers would typically look at the SDLC. Right, so how do we sprinkle on security? Let's sprinkle a little bit of that security magic. So my first thought when I put this together is, this is a lot of stuff, right? Do we really need all of this stuff to secure software in 2024? I'm not going to go through every one of these, but I want to call out that really you can see under things like development, there's multiple ways to do things. And if you watch a lot of other application security presentations or read books where they talk about these things, then you might get pros and cons, but what you don't really get a sense of is, what do you need to do? Right? There's a ton of stuff here. If your application security program is just a few people relative to the size of your engineering org, how are you supposed to look at this and decide where you should focus? You know, it's interesting. An interesting metric to think about is how many application security people you might have at in your InfoSec org compared to the size of your engineering org. And realistically, if you have anything less than about 80 engineers to one AppSec person, you're doing pretty good by industry standards, right? Often it'll typically be more towards like 100, could be like anything, you know, could even be north of that, 150 people. Hell, maybe you're the only person working in AppSec and you've got a whole engineering org. So when presented with this, where the hell do you start? Like, how do you, like, what do you pick? What are you going to double down on, right, when everything seems to be important? So what we need to think about is, do we need to do it all? And there's 3 kind of overlapping lenses here. The first one is an adage that you'll get in every management book. You'll also get it in every engineering management book. But strangely, it doesn't really come up in InfoSec books. And that is, if everything is a priority, nothing is. Right? I think in many ways we like to think in InfoSec that we're kind of special and everything truly is a priority. Right? But this saying is so true. You really can't focus on everything. You've got to be intentional. This second lens, also from engineering, is from an engineering blogger called Jade Rubik that talks about different personas in engineering to speed up the velocity of an engineering team. And one of these is subtractionism. It's essentially just asking constantly, do we really need to do this? What if we don't do this? What if we do this later? What will the impact be? So really like getting you to think about trade-offs. And this last one here is from an information security blogger, Phil Venables. And he talks about knowing when to go for an A grade versus knowing when you simply need a pass. So putting all these things together, we can really kind of start to think about technologies and processes as, right, we want the A grade. We're really going to intentionally do this thing, and we're going to do it the best we possibly can. Or we just need a pass. Like maybe we're required to do this from a compliance perspective, from a regulatory perspective. We have to do it, right? But we're not going to kill ourselves doing it. We're just going to do a best effort, get the pass, accept it, move on. And then lastly, there's going to be a whole bucket of things where we don't have any real reason to do it. Maybe it's not going to be a good fit for our organization, so we're just not going to do it. All right? And in a nutshell, that is my talk. You don't have to do it all, despite what application security bloggers and books and presentations will tell you. You don't need to do it all. So let's go through a few of these things. I'm going to do a whistle-stop tour. Actually, I should have said this at the start, but my talk's in two parts. First part, we're going to do this whistle-stop tour of a bunch of these tools and technologies and processes. I'm going to share some thoughts on them. And then the second part, I'm going to share my version of how we do AppSec, and we're going to layer on these processes. So application inventory. Firstly, a truism here, you can't secure what you don't know exists. I'm sure we've all heard that before. In fact, if you were to poll a list of CISOs over the last decade and ask them, like, what was your #1 initiative, it was probably something around visibility, right? Just understanding, like, what we even have to secure. So I'm definitely a big believer that we need to know in AppSec what it is we need to secure. In the olden days, when cavemen were writing code on stone tablets, and essentially we were building monoliths, who here is familiar with the concept of a monolith in application security? Okay, a bunch of you. For those of you that are not, a monolith is essentially a giant slab of code that has everything for an application to function in one repo. It's going to be the presentation layer, the business logic layer, the data access layer, some giant code base with tons of developers working on it. Now, monoliths have fallen out of favor pretty dramatically over the last decade or so, largely because of the perception that they're really hard to maintain. All of these engineers working in the same code base is a nightmare. Ownership is unclear when you've got so many people working in there. Its release cadence is slow because there are so many moving parts that you have to get right before you can deploy it. Now, arguably, some of those things have been solved, for example, in a repo with the code owners specifying ownership. You know, it's a really nice way that you can control who's committing to that repo. But actually, monoliths have one real major benefit, which is you don't have many of them, and you know what they are, and you know where they're deployed, and you know when they're deployed, right? So that means we can use Stone Age tools like Microsoft Excel for tracking our monoliths. And it's not a crazy idea because these monoliths are not changing dramatically over time. So keeping track of them on an Excel, it's not immediately out of date the second you write that Excel. Like it's going to be a pretty good source of truth. So that's monoliths. So in the old days, keeping track of what you had was actually reasonably easy. But enter microservices. So as we moved away from monoliths, we came up with microservices where we essentially decomposed different parts of that application into domain-specific services. So you can see here on the left this picture I stole of microservice architecture where we've got a handful of microservices doing different things. The concept makes a lot of sense, right? These services are owned by individual teams. For example, a team owns the data access layer, another team owns front-end code, another team owns different parts of your business logic. Makes a ton of sense. But somewhere we kind of lost track of why we were doing microservices, and we ended up with something like this, predictably. So we ended up with this nightmare scenario where we have not dozens, maybe not even hundreds, thousands of microservices in some cases with, and mapping the interactions between these, it's a complete mess. Ownership of these in a lot of companies, super unclear. And actually there's a really interesting quote here from the former CTO of GitHub who basically says, like, we've done all this work to move to microservices, but honestly, most things could probably still be a monolith in most companies. So it's a classic case, potentially, of like engineers like over-engineering, right? So we end up with this nightmare scenario of microservices. And then how do we keep track of this? So in the microservices world, how do we actually know what we need to secure? Well, that is actually not the question you should be asking. The question you should be asking is, who should own keeping track of your microservices, right? Now, think about the orgs at your company. It's obviously not going to be legal, HR, finance, comms, anything like that. Really, the only two options are us, InfoSec, or engineering. And I'll give you a clue. It's not us. Your engineering org, as microservices takes root in your company, your engineering org must be responsible for knowing what you have, right? And that needs to be more than just saying, well, go look in AWS at EKS or ECS and you can see what we have. No, we need a better list than that, need a better inventory than that, right? We need to know what engineering squad owns a service. We need to know where the code is. We need to know where it's deployed, what environments. We need to know where we can file tickets for this thing. We need a whole bunch of metadata. And engineering really have to be the ones that own that. Now, InfoSec, we can partner with them. It's a great opportunity for InfoSec to be kind of stakeholders and demonstrate collaboration and all that good stuff. But InfoSec should absolutely not be the ones building it. So my advice is, if you're struggling with that in your company, go have a conversation with your engineering leaders, with your CTO, and pro tip, if you can make them think it's their idea, then obviously you stand a good chance of success there. It's a solved problem from a technology perspective. There's commercial solutions and there's really good open source solutions. Hat tip to an open source project called Backstage, which was created by Spotify for really having really great management of everything that you have. Okay, let's talk about something different. Let's talk about training. Who here, quick show of hands, who here plays video games? Okay, lots of you. Who plays CTFs? Okay, still a good number. Who here likes mandatory HR and compliance training? You, sir, a unique individual. Now, what if we took that mandatory HR and compliance training and gamified it? You want to play that game? No one wants to play that game. You're not that jazzed about it. Herein lies the problem with gamified information security training. All right, it's affinity bias. We like video games, we like CTF, we like InfoSec. Therefore, we're going to push gamified training on you, gamified security training, labs on you, and we're going to on engineers, and we're going to expect our engineers to enjoy that. Unfortunately, they won't, or at least a large percentage of them won't. Now, some of you will probably be thinking, but we rolled out this gamified training at our company and for engineers, and it was a wild success. All the feedback was super positive, right? But the feedback you're getting is from the people in engineering, that small percentage that like playing games and like InfoSec and probably don't even need to learn anything from the training because they know it all already, right? You're not getting the people that really need to understand that knowledge to actually engage in it. So it's a hard no from me on gamified security training. How do we do training? Well, firstly, be guided why you're giving the training. So think back to that quote from Phil Venables of, are we doing this just to get a pass? Like, do we have regulatory or compliance reasons? Like PCI DSS 4, for example, you got to train your engineers. Okay, we have to do this, right? Or is training something that maybe organizationally your company is used to training and loves it and does well with it. So maybe training is the thing that you want to double down on and be like, we're going to really put a lot of effort into this and make it great. If that's the case, how do you do that? Well, firstly, know the tools available to you at your disposal. Go talk to your HR team. You probably have a learning management system that you can use. Your HR team may be able to help you with that. They may even have resources or budget to help you with that, so have those conversations. They could help perhaps with tracking completion and all those pesky details that we hate to do as InfoSec, which frees up your time to then really focus on creating contextually relevant training. Yes, I'm advocating that you write your own application security training. Now, that may sound like a daunting task. It's certainly time-consuming, but it'll be super relevant, and anything relevant is going to get more traction. It's going to be more interesting. And probably the pace of technology in your company doesn't change so fast that the training needs to be updated that often. So it's an initial investment of time, and then you've got this great contextually relevant training you can roll out to engineers. I've had great success doing this, really using examples of real bugs that we've had, literally even linking to JIRA tickets in the training so engineers can go and see, oh yeah, this was a real bug. And lastly, you know those kind of trainings where they have a minimum time limit, right? That mandatory HR and compliance training where you've got to spend like 2 hours on the thing, right? How many engineers or how many people in your company do you think are on their multi-monitor setup have got your training in one window with that timer ticking down, and then in the other window they're on social media or watching Netflix or something, right? Don't bother with any time limits. Build goodwill with your engineers. Let them whip through it if they really want to. Just put a test or something at the end so you can make sure that they're testing out, so you can show your auditors, etc., that they did it and passed. All right, let's keep going. Threat modeling. Who here is familiar with the concept of threat modeling? Okay, good number of you, so I'll just go really quickly through this. But for those of you that are not familiar, threat modeling. The premise is this: we want to find design flaws as early as possible. So really, ideally, before our engineers start coding, or at least early in the process, so that if we have to have them make changes, these changes aren't expensive, because the later we get in the engineering process, the more expensive it's going to be, the more time-consuming it's going to be to actually make significant changes, right? So you want to catch all this stuff up front, catch these design bugs. So the way it works is your engineers come to the meeting that you've set up, and they bring this beautiful data flow diagram, like you can see on the left, and then you pair that with a methodology. The one here I'm showing is STRIDE. It's an acronym for those different types, those different classes of vulnerability, but there's various different methodologies and also various different ways that you can draw those data flow diagrams. But that's the general premise, right? But I want to back up a sec. Wait a minute, how did we even get to that meeting where engineers came prepared with this beautiful diagram? Right? In a lot of companies, there's really not the communication between the product side and your information security side. Like, how many times have you worked in a company where you've seen an announcement about some new thing, some new application, like some announcement to the company, this thing's now live, and in your InfoSec team, you're like, wait a minute, has anyone even heard of that thing? Did we do a review on it? Right? So what I'm really advocating for, first of all, is that threat modeling is kind of less useful if you don't have a rock-solid relationship with your product team, if you don't have a process to know everything that is coming up. Because if you don't have that, then ultimately you're probably missing threat modeling stuff that you should be ultimately threat modeling. And secondly, how do we expect our engineers to produce all of this material? These beautiful data flow diagrams. Right? They typically won't produce a diagram like this during their normal engineering work. They may produce like UML sequence diagrams or other diagrams in their specs, but they're not producing data flow diagrams. So you're magically expecting them to not only know how to do this, but also invest the time into doing this. That's unrealistic. Right? You have to train your engineers, then you have to persuade them on the value of this. And lastly, a phrase that I've refrained from using until now, but you hear in every AppSec presentation, here it goes, shifting left. Sure, we've all heard that. Essentially, it means we're a small InfoSec team. To scale security, we have to make it the developer's responsibility, right? So you often hear of initiatives in AppSec where threat modeling groups are run by engineers. But the problem is this: what if the engineers don't know the threats? Like, how useful are your threat modeling sessions going to be? So really, let's look at the guidance here. So going back to what I said, the first point is really need to focus on identification and prioritization of what needs threat modeling. This idea that fewer really high quality threat modeling sessions on the things that are truly critical that you're releasing, that's way better than trying to scale a threat modeling program and have lots of shitty sessions where essentially nothing really gets done, no good action items come out of them, and engineers eventually kind of lose interest in them. Right? So much as I would like to democratize threat modeling and have InfoSec take more of a backseat, if you're starting to roll threat modeling out in your organization, InfoSec needs to be really front and present in all of the sessions, right? And then it becomes a scale problem. So you really need to be very focused. And lastly, we do threat modeling to identify threats, and those may be in the form of design issues, or they may be concerns about implementation. But the implementation isn't done because, remember, we said we're doing this before the engineers write code. Right? So the two outcomes you might get are tickets to go and change the design, or tickets to around concern about the implementation. Like when you've written this as an engineer, like assign the ticket back to me because we want to review it, like targeted code review. So you really need to make sure that your actions are tracked, right, and completed. Because if you're not tracking your actions and you're not completing those actions, why are you even bothering with threat modeling? So that's a really nice metric you can measure when you roll out threat modeling. Like how many action items do we get out of every meeting and what's the completion rate on those? Let's keep going. Static application security testing. So SAST has been around for a long time now. Here's a diagram I stole to show how it works. Essentially, it's automated analysis of code to find security vulnerabilities. We feed in our source code into a system. It may produce an intermediate representation. It then takes a set of rules, typically vendor-provided rules or community rules. You can also, in most systems, add in custom rules. And then it uses some combination of those technologies in the box at the bottom, everything ranging from simple pattern matching through to more complex processes like control flow analysis or taint tracking, so tracking where how user input flows through your application. Like in premise, like a lot of these processes, the premise is good, right? It's a source of vulnerability. Now, in the days before shifting left, SAST used to be run by security teams. But remember, that doesn't scale, so we have to force it onto our developers now. But in those old days, there was sort of an implicit understanding that SAST wasn't that good. That SAST would throw up a ton of false positives, and hey, we're on the security team, we're used to this, we would do the triage, and we would sort of quickly get to eyeball it and say that's a false positive, etc. Now the problem when we shift that onto developers is developer gets a finding, and they spin their wheels, they spend time trying to understand it, and then they can't. They're like, this doesn't seem to be a bug. What am I missing? And they come back to the InfoSec team, and InfoSec then look at it, and InfoSec then say, oh yeah, this is false positive. Developer goes away. Next issue for triage, same thing happens. They come back to InfoSec, oh yeah, another false positive, another false positive, another false positive. We're essentially training engineers to think that SAST doesn't work, right? And that is the big problem. Because a lot of these tools, they'll throw out the findings and they'll tell you the severity. What they won't tell you is confidence. They won't say, this is a critical vulnerability and I'm 95% sure of this, or this is a medium vulnerability and I'm 10% sure of it. If we had confidence, we could at least like set a bar and say, okay, anything that's less than, I don't know, some arbitrary value, 80%, we're just going to throw away, and really the stuff that we're really sure on is going to go to developers. But most tools don't work that way. So we end up training our engineers that SAST is effectively pointless, and then eventually it withers and dies. How do we get past this? Okay, that top point, another way of saying what I just said, false positives kill developer goodwill. Right? That's the biggest takeaway you need for SAST. Another limitation of SAST is it can't find business logic bugs. It finds kind of implementation bugs. So imagine you're developing a banking application. SAST, with just a default rule set, is not going to be able to find a business logic bug that lets you transfer money that you don't have from somebody else's account into yours. It's just not. It doesn't. It's pattern matching in your code. It doesn't know what your application is designed to do. How do we make SAST useful? Well, we really need to focus on true positives. So take that rule set and over time, just ruthlessly pare it down. Ruthlessly pare it down just so you have a few very well-defined scenarios with a super low false positive rate, right? So engineers are getting high signal because, again, false positives will kill developer goodwill. Let's talk about DAST, dynamic application security testing. So unlike static application security testing that focuses on code, dynamic application security testing focuses on a running version of your application. Now, normally a DAST scan takes a bit of time, so you might kick it off in a CI/CD pipeline, but it's not going to be synchronous. You're not like, the pipeline is not waiting for DAST results to come in. So often we end up just kind of scheduling DAST scans against our dev or our test environment, maybe, you know, once every release or like once a day or something like that. In the old days, we used to build applications around a very page-centric model. So depending on how long you've worked in InfoSec, you may remember applications built around technologies such as Java servlet pages and PHP, I guess we still use that, active server pages, even sort of ASPX superseded by aspects of ASP.NET. But it's a very page-centric model for building applications. And what I mean by that is different pieces of functionality in the application were encapsulated by different pages. Login would be a page, checkout, the various stages of checkout would be their own pages. Everything's sort of neatly encapsulated in a page. And this worked really well for DAST, because DAST has two real jobs. It needs to find all the entry points into your application, and it needs to know essentially how to call those entry points with fuzzed data. Right? It'll generate requests, it'll look at the response to those requests, and try and identify any security vulnerabilities. So this page-centric model worked well because essentially it was easy to do, or easier to do those two things. We could just look at the HTML response that comes back. We could essentially grep that looking for interactive elements like forms, buttons, etc. And then we would get to learn like of new pages that we should test. And we could look at the form fields and we would know, okay, these are the parameters that we need to call that page with. So that model kind of worked well. Now, where things went off the rails with DAST is about 15 years ago, we started moving towards single-page apps. So a single-page app is basically one page in your browser that's using JavaScript, a giant blob of JavaScript to encapsulate all of your front-end logic. And that JavaScript is making dynamic requests to an API, to your application's API. Now that might be a private API, as in it's publicly accessible, but it's only designed to be used by your front-end application, or it might even be a public API as well, an API that you expose to your customers. But either way, you've got this single page and the JavaScript making all these API calls. Turns out this was a nightmare for DAST, and to be honest, DAST is still trying to catch up. It's a nightmare because DAST can't magically then determine all of those entry points. It can't analyze that JavaScript, that giant blob of minified JavaScript. It can't analyze that to know exactly what the endpoints are, exactly how to call them, like what are the headers it needs to put, what is the body of the request it needs to put, and what is the sequence of calls that it needs to make. Right? So DAST really struggles with that. How the industry got around that is that most DAST tools allow you to record macros. They allow you to essentially capture traffic and then feed that to the DAST tool, like templatized traffic, so DAST can see, okay, here's a sequence of requests representing login. I have to send this request first, and then this one, and then this one, and here are the parameters. Okay, that works, but that doesn't scale, right? You're telling me I have to go through and record a macro for every piece of functionality on the site, and anytime anything changes, I need to like redo this process. It's a nightmare. So how do we make DAST work? Well, that first point here, DAST can't automatically go deep into flows without significant prep work. Who's going to be doing that prep work? Well, it's probably going to have to be us, because we're the owners of the DAST tool. And that's time consuming. Secondly, kind of like SAST, DAST won't magically find these high-value business context, contextual business logic bugs. So take the banking example. Again, DAST is not going to magically find that you can transfer money out of an account that you don't own. One possible saving grace for DAST is that if you have a dedicated QA team that tests software, if they have ways of testing your applications in an automated way, they've kind of solved a lot of these problems. They've actually solved this idea of like, how do we log in, right? They've built specific tests, automated tests that will test these parts of your application. They'll figure out how to log in. So if you're willing to put the work in, you can kind of solve that problem of needing to generate macros for your DAST tool by partnering with QA. So if DAST is something that you really want to go all in with, then that could work. Go talk to your QA team. Something I probably should have said earlier as well is that when I showed that slide of all the different technologies, any one of them done well can improve your security posture. So this talk is less about like perhaps which ones you should do and which ones you shouldn't. It's which ones you're going to intentionally go all in for and try and get that A grade. Let's talk about paved roads. This is a concept that the security team at Netflix have been speaking about for a good number of years now. Essentially, we need to come up with templates for secure configurations, for libraries and microservices. We then want to incentivize our engineers to use these things when they're building their microservices or when they're pulling in their libraries. Right? And if we can incentivize them to do that, we're going to get all this great benefit because these libraries are going to be secure, right? They're going to be vetted by us. So how do we incentivize engineers to do this? Well, we make these templates really enticing from an engineering perspective. We basically load them with all of the scaffolding that engineers would need to spin up a new microservices project. So we stick in all the configuration management code, all the observability stuff that's required for observability in your company. We put logging code in there. We do the standard secrets management stuff. So it's really enticing for engineers because they have two choices. They can go the non-paved road way, spin up something from scratch and spend like a whole bunch of time having to put all that scaffolding in, or they can just fork the paved road approach and just get coding on the thing they actually want to build. So this is a rare scenario where it's done well. It's this win-win. It's this potential, like engineers will want to use the thing and you get all this security benefit. So what's not to like? Well, ownership and maintenance can become a bit of a nightmare. Often you'll find that ownership isn't well defined. Maybe this was a hobbyist project. Engineering leadership never bought into this. You know, somebody in your company in engineering did it as in their spare time, and everyone then forked it. Then that person leaves the company, moves teams, or gets too busy to maintain it. And then what happens? A new log4j2 comes out, and InfoSec goes to the owner of the template. Hey, we need you to patch this, and they're like, I'm too busy, or no one knows who owns the template anymore. So you really need to be explicit about that. Engineering leadership really need to buy into this concept. And then tracking template lineage in CI/CD. Everyone's forked it. Everyone's on different versions of it. That can become a bit of a nightmare. And then let's say the expectations on when upstream changes are pulled. So let's take that log4j2 example. You've got templates. You've fixed it in the upstream template. You know where all the forks of that template are, like everyone that's using that template, and you go to those teams and you tell them, okay, you gotta fix it, you gotta pull in the changes from the template. But there's a good number of teams that last time they pulled in changes was 2 years ago, or 3 years ago, and there's like breaking changes, and they're refusing to pull in those latest changes because they're like, whoa, this is a ton of work, like, and they didn't stay up to date with those changes. So those are kind of things you need to think through. Like, in short, paved roads, great idea, but it's got to have strong buy-in from engineering, otherwise it won't work. Okay, last process I'm going to go through. I'm sure you're all familiar with bug bounty. This idea of let's pay security researchers to find and responsibly report security issues in our code. Premise sounds absolutely great. You're only paying for issues. So what can go wrong with a bug bounty program? Well, here's how it typically plays out. You'll decide you want to do bug bounty. You'll go talk to one of the 3 major vendors that runs the platforms. They'll give you a quote. You'll like fall off your chair when you get that quote saying like, why is this so expensive? Then you'll decide we can run this ourselves. How hard can it be? We just need a pool of money, right? And then we don't need to pay the platform. So you start your program, you publish something on your site saying like, send us the bugs, and then you get deluged. You get deluged with junk reports. And you spend all day looking at these junk reports, trying to separate the wheat from the chaff. Right? That is why these platforms exist. They exist to do the triage and give you the strong signal out of all the chancers out there that are submitting bullshit bugs. Okay? And that problem's only going to get worse with AI. If you look at the curl project, for example, there's some really comical examples of just like AI-generated bugs that have been submitted. That unfortunately, it's an asymmetrical problem. The people on the triage team have to then spend time like understanding, is this a real report? Is this bogus? So running bug bounty is work. How do we solve this? Well, you probably, unfortunately, need to spend the money and use a platform. You need to continually refine your scope to eliminate the noise. If you get like findings you're not interested in, okay, figure out paying it out or not, but refine your scope so you don't run into that problem again. And make use of bonuses to really steer researchers onto the parts of your application that you really want scrutinized. And lastly, how do we think about effectiveness of bug bounty? Because number of bugs, which is a primary metric, it's a shitty metric. Like, what does it tell you? If you don't get any bugs, what does that tell you? Does that tell you that your software is secure? Or how do you know? Are people even looking? Right? So you should really think about what the metrics are. But in the interest of time, I'm going to move on to part 2. This is just a few slides. We're going to talk about the power of true positives. This is not self-help for InfoSec, though God knows we probably will need it. Instead, this is how my approach to doing application security. Security tooling considers the entire universe of vulnerability classes, right? If we think about running the program forward, like the stages of the SDLC, we are focused on that entire universe of like what could go wrong. We're trying to catch it, prevent it, detect it as early as possible. What I like to do instead is focus 90% of my effort going reverse. I like to really focus on true positives, those verified vulnerabilities in your production environment, because you may not realize it at the time, but they have so much power. They have so much value for you understanding how to improve your security program. So the true positive process. Now, on the left here, how do we get sources of true positives? Okay, here's a non-exhaustive list. It's pretty straightforward. We get them from pen tests. Like, you know, here's a nice write-up of a real bug. We get them from bug bounty once we've triaged them. We might get them from ad hoc testing from the InfoSec team. We might get them from our QA team. If you're working for a company that sells to government or other businesses, you might get them from B2B, from your customers. So we've got a source of these vulnerabilities. So what do we do with them? Okay, we start from the true positives. We figure out the root cause of those vulnerabilities. Now, this is not just file a ticket for engineering and walk away. This is partnership with engineering to really understand what the problem was. This is also not just read the pen test report and summarize it at a high level. It's input validation, or it's SQL injection, or it's something else. It's work with the engineer to really identify this is where the problem is in the code. Everyone needs to understand that, InfoSec and engineering. You then abstract that to the anti-pattern. What are the characteristics of that particular vulnerability, that class of vulnerability, and how widespread is this? That's what you're ultimately asking. Because what you don't want to do is play whack-a-mole. You don't want to just fix that, have the engineers fix that vulnerability, and then a month later you get the exact same vulnerability reported in code 2 lines below. Right? You want to look holistically across all of your code, all of your engineering teams, and ask, is this vulnerability, is this class of vulnerability widespread, or is it just ad hoc? And that really helps you prioritize. So let's say we've got some systemic vulnerability, some critical systemic vulnerability that we've abstracted to an anti-pattern. Well, you of course work with engineering to fix that. But then the final step of the process, it's future-proof with countermeasures. We need to take all of those processes and technologies that we've discussed in part 1 of the talk, and we need to figure out how do we use those to eliminate this entire class of vulnerability forever. That is how you get better at AppSec, by eliminating entire classes of vulnerability as they come up one by one. Right? And typically there's no panacea. You're probably going to need to use a bunch of those tools and processes to actually solve this problem. So maybe you need to add dedicated training to your engineers about that specific type of issue. Or maybe you need custom static analysis rules, or if you use DAST, or you tune DAST to look for those types of issues, or you work with your QA to hunt for them as well. Or you have a bug bounty campaign where you pay double for those types of issues. Lots of things we can do. Rinse and repeat, eliminating entire classes of vulnerability. Quick word on ticket trade-offs. I really like this graph because it basically shows, let's say we have a vulnerability from one of those sources, bug bounty or pen test, right? It basically shows how long it will take for an engineer to fix that. If you just copy-paste, put that in a ticket, it's going to take a long time to fix that because an engineer has to pass through it, understand what it's really saying, translate it into contextually relevant information for them, for the organization, and then figure out how to fix it. The alternative approach is you, like us. We could spend a lot of time doing that triage, doing that discovery, writing a beautiful ticket, translating it from the language that the researcher used into words that are really meaningful for our engineering org, and then proposing exactly what the fix needs to be. Right? But that's super time consuming for us. But if you do that, I guarantee your ticket will get taken care of and fixed like super quickly. So there's no right answer of how much effort we need to put into our tickets, but it's something that you will need to think about when you're filing those tickets. And you need to know like the two ends of that spectrum. If you just copy paste and file that ticket, it's going to be a slow, like bumpy road to get it done. If, however, you really focus on making those beautiful tickets, tons of detail, it'll get done quickly, but how do you scale that? Right? So you've got to think about that sweet spot on that curve that works for your org. One more thing on the correctness of fixes. So I think a lot of this is stating the obvious, but who reviews security fixes? You may have other engineers just giving a quick looks good to me or a quick thumbs up. And you may ask, well, doesn't retesting cover it by the pen testers? Right, what I'm going to advocate for is that InfoSec really understand the bugs and do some level of validation on the fixes themselves, ideally walking through the code with engineers. Wait a minute, so you're saying we have to do this for all bugs? Of course not. You need to figure out critical bugs, obviously, but figure out what works with the bandwidth that you have on your team. But correctness of fixes is hugely important. If you're not fixing issues correctly, then they will eventually be rediscovered, and it will be even more work for engineering. Okay, takeaways. Firstly, I have unicorn sugar cookies for everyone. I'm just kidding, that PowerPoint template just came with it. Really just two takeaways. Be super intentional about how you layer security into your SDLC. Right? Remember, are you just doing it for the pass? Or is it something that you're really going to double down on, get that A grade? Or do you just not need to do anything? Or you just not do that thing? And then think about this concept of running things in reverse, learning from true positives, and really eliminating classes of vulnerability one by one, because that is a meaningful way to improve your application security posture. Thank you. That's all I got. I'll be around for the entire day. Would love to chat to you all about application security or anything else. Thank you.